Okay, here are some homework problems from section 3.2. It says complete the table and find the balance A for these problems right here. So you're giving you different compounding ways: annual, biannually, quarterly, monthly, daily, and continuously, and different principles, rates, and number of years. So this first one here, problem number 1, let's do this one. You're depositing $2,500 at an interest rate of 10%, 12% for 10 years, and let's fill in this blank right here where it's compounded annually, one at a time. So we go to the banking sheet, put in on the left-hand side where you see this formula, put in the P of 2,500, the interest rate, type in either 0.12 or you can type in 12%. The N, filling in this area right here, the N is 1, so put 1 in, and the number of years was 10. And you get your amount right here. It just uses this formula right here, and it gets the amount to be $7,764.62. If it asks how much interest did you earn, well, this is the interest that you earned right here. And to do this one with the N equals 2, just change the N right here to 2. And if it's quarterly, when it's 4, just put a 4 in, and monthly put 12 in, daily put 365 in. To do continuous, you have to use the right-hand side of the sheet. So over here, put your 2,500 in, your 0.12 for your interest rate, and your 10 years, and you'll get $8,300.29. And that's the way all those work there, 1 through 4. Let's go to 5. 5 says in these exercises, complete the table and find the amount P that needs to be deposited to obtain a balance of $100,000 in 10 years. So this is the amount that you want to end up with, is $100,000. Now it's giving you, in T years. Now what's the T? Well, two places here, 1 year and 50 years. So let's just fill in this spot right here, 50 years. And let's do problem number 5. The interest rate is 9% compounded continuously. Well, if it's compounded continuously, you're on the right-hand side of the sheet. We're finding the principal, so that puts us in this little square right here. The amount we want to end up with, told us in the problem, is $100,000, so put that right there. The interest rate, it told us right here in problem 5, is 9%. And I'm just filling in one of these blocks here, the 50 I'm filling in, so just put a 50 right in here for T, and the amount that needs deposited, your principal, is $1,110 and about 90 cents. And if you want to get when it's 1, just replace the 50 with a 1 and you get it. Let's do down to problem 7. It says 10% compounded monthly. Well, if it's any sort of discrete way, you use the left-hand side of the sheet. So we're using this area, then finding principal, you're using this area right here. Want to end up with $100,000, 10%. Compounded monthly, it says here on problem 7, so put a 12 in here, and it's after, I'm just filling in this spot, 50 years, so put a 50 in, and you would have to deposit $687.90, a one-time deposit of that much money at this interest rate, and in 50 years you'll end up with $100,000. Okay, so let's move on, and that's the way all these are done right here. And then let's move on to problem number 9. On problem 9, it says you deposit $25,000 in a trust fund that pays 8.75% interest compounded continuously on the day your grandchild is born. What will be the balance of this account? What will the balance of this account be on your grandchild's 25th birthday? Well, it's giving you there's going to be 25 years, and here's your principal. Here's your interest rate, and it's compounded continuously, so we're using the right-hand side of the sheet. So I'm over on the right side of the sheet. We're looking for a balance, how much amount of money that you end up with. So I put $25,000 in for P, 8.75% in for R. I actually typed in 8.75 with the percent sign, so you can do it that way, or you can type in 0.0875, no percent sign. Either way will work. The T is 25 years because it's from born until she's 25 years old, so that's 25. So how much money will be in there? Well, $222,822.57. Okay, so let's go on to 11. Okay, on problem 11a, it says, what annual interest rate would you need to receive to equal a quarterly interest rate of 10%? So I'm keeping track of two different banks here. This one is my annual interest rate. That's why the N equals 1. And over here is my quarterly interest rate. Okay, and I said quarterly interest rate of 10%. So n equals 4, and the rate is 10%. It said, what annual interest rate do I need? So I put a question mark here next to the R because I don't know what annual interest rate I'll need. Now, to compare these two banks, I have to put in the same amount of money over the same amount of time. You can let P be whatever you want to here, but you got to let it be the same thing here. So I'll let both the P's equal $1. And you have to compare it over the same amount of time for both banks. So I let T equal 1 here and T equal 1 there. You can let T be whatever you like, but just make sure it's the same in both places. So now, the only thing I don't know over here is how much money I'll end up with. So I go to my bank sheet, use the left-hand side of that, and right here at the top, I'm figuring out the amount of money I would have if I put in $1 for 1 year at 10% compounded quarterly. So I put in $1, 10% quarterly for 1 year, and I end up with 1.10381. Now carry all those decimal points and type that in here, or you can do this, equals, and just click on this, and it's actually more exact. It's carrying a lot more digits of precision. You don't see them, but it's carrying more precision if you do it that way. Now, this is the amount of money that we have in this account, and we're wondering what rate do we need to equal this account, so it has to have the same amount of money. So I just put the amount over here, the 1.10381, and now I say, what interest rate am I looking for? That's why I'm down in this area. The principal is $1. The N, it was compounded annually here, so that's 1. And the T is also 1 for 1 year. So the interest rate needed is 0.103813 to be real exact. So whereas the quarterly interest rate so this means that a quarterly interest rate of 10% is equal to an annual interest rate of 10.38%. And we'll go on to do problem B. Okay, problem 11b says, what annual interest rate would you need to receive to equal a continuous interest rate of 10%? Okay, annual, n equals 1. What annual interest rate? Don't know what annual interest rate, so I put question mark right there. So to equal a continuous, okay, with a continuous you don't type in the n. Okay, the n is actually approaching infinity. Continuous interest rate of 10%, so the rate is 10%. Again, comparing the same amount of money, we'll just use $1. Over the same amount of time, we'll just use 1 year. So over here, I have all the information, and it's continuous. I can figure out then from this information right here what the amount ends up to be. So on the continuous side of the sheet, I put in $1, 10% for 1 year, and I get this 1.10517. So that's 1.10517, I believe. 1.10517. And now see, that's the amount that this bank has to end up with too. So over here, where I'm figuring out the interest rate, and it was a discrete type of thing, it was annual. So right here, type in the 1.10517. Then principal of $1, the N is 1 because it was annual. And the T is 1 because we left both sides equal 1 for the time, and we get an interest rate of 10.517. So in other words, an interest rate of 10% continuous is equal to an interest rate of 10.52%, rounded to the nearest hundredth of a percent. Okay, problem 12 says graph y equals 2 to the x, y equals 2 to the x minus 5 plus 6, and determine how much the graph of this one has shifted either up, down, to the right, left, compared to 2 to the x. Well, to get the amount that is shifted up or down, that's just the constant at the end. So this has been shifted up 6. And then the amount right or left, what you do is set what's in parentheses here equal to 0. So if you set the x minus 5 equal to 0, you'll get x equals 5, positive 5. So that means that it's been shifted to the right 5. So to the right 5 and up 6. Now you can graph these exponential functions on the exponential sheet, the sheet right after the bank sheet. And if you scroll to the right on that, see, you can't type something in y equals 2 to the x here because the base is always e on this first one. If you go to the next one, it's the same thing. The base is e. It just leaves you a little shift up or down thing with the plus c. But the third one over, gives you a place to take anything raised to an exponent, and the one we're doing is 2 to the x, so I'll just put a 2 in here for the a, and I also need to put a 1 in here for the b because the bx here. So there's the graph of 2 to the x. Let's go from like, I don't know, -3 to 3 or so. So there's a graph of 2 to the x. Now, this one, y equals 2 to the x minus 5 plus 6, well, just putting in your coefficients here, the a is 2, the b is 1 because we have 1x, the c is -5, and the d is 6. And if you put that in there, it shifted the graph up. You can see now instead of being a horizontal asymptote at 0, the horizontal asymptote now is at 6 up. So the horizontal asymptote is at y equals 6. It's been shifted up 6 units, and it's been shifted to the right 5 units. And so that's how you would do these right there. And I'll stop right there.